My name's Emiko and I'm a long distance runner. Have you ever wondered why you get so sore after a long distance run, or question why are you even trying to work out if you're always so sore the next day? Well, this is all because of polylactic acid, lactic acid, or PLA for short, which is all part of the alpha-tic polyester family commonly created from alpha hydroxy acids. An alpha-tic polyester is also known as a biodegradable polymer. Lactic acid is an organic compound. Its structural name is 2-hydroxypropanoic acid, and consequently, its formula is found here. When found as its conjugate base, it is also called lactate. When lactic acid is in a solid state, it is white and water-soluble, and in a liquid state, it's colorless and clear. Lactic acid has a relatively high boiling point of 122 degrees Celsius and is miscible in water and has a pH of 2.4. Lactic acid can be decomposed through hydrolysis, or the adding of water molecules of the ester bond, and this does not require any enzymes for the reaction. The rate of decomposition depends on the size and shape of the molecule, as well as the temperature at which the hydrolysis takes place and the isomer ratio. Lactic acid is a weak acid, meaning it only partially dissociates in water. When this partial dissociation occurs, it breaks into H pluses and the ion lactate. This is a reversible reaction, and the equilibrium is represented by this equation. Lactic acid can be made naturally and synthetically. In the human body, lactic acid is produced by the muscle cells from glycogen when there's a lack of oxygen to support the production of energy. You are often sore after a workout because during the exercise there may not be enough oxygen available for the breakdown of glucose for energy, which produces lactate. Lactate can be converted by your body without the use of oxygen. However, it often builds up faster in your bloodstream than your body can burn off. The lactate threshold is the point at which the lactic acid begins to build up in your bloodstream. Lactic acid can be produced commercially by the fermentation of carbohydrates, including lactose, glucose, and sucrose. So now you know why you're always so sore. However, let me tell you a little secret. Runners like me still get sore after a long distance run, and it happens to almost everybody. The key is to keep pushing through, and over time you won't feel as painful. Now we're going to scientist Madison, who will talk to you about the equilibrium equations of lactic acid.
Thanks, Emiko. Lactic acid formation occurs when the human body reaches a point where we can't take in enough oxygen supply. The specific point where our bodies reach the maximum amount of oxygen intake for our working muscles is known as the anaerobic threshold. Past this point is where lactic acid formation occurs. This can become chemically very complicated. Here you can see the chemical reactions that produce lactic acid from pyruvate. The role of NADPH is to drop off the hydrogen plus molecules onto the pyruvate, converting it into an acid. You see, there's this thing called chemical equilibrium, where a reversible reaction in a closed system is occurring at the same rate in the forward and the reverse direction. A chemical reaction always strives to reach equilibrium. Now relating this back to lactic acid threshold during exercise, the chemical reaction of lactic acid formation is balanced when the rate of the formation, utilization, and elimination of lactate is equal. Once the runner has passed the lactic acid threshold point, this equilibrium is affected and the production of lactate is increased. This means that the levels of lactic acid in the blood are also increased. As the intensity of the exercise increases, the lactate is accumulated in the muscles, causing them to stiffen. When the medulla oblongata in the brain senses a decrease in the blood pH due to the lactic acid, it shifts the equilibrium to restore the natural pH. This is done by the blood's natural buffering system. The blood uses the bicarbonate buffering system to regulate any changes in the pH. In this case, would add a base to the blood to increase the pH back to homeostatic levels. Here you can see the chemical representation of the bicarbonate buffer system converting the lactic acid into water, carbon dioxide, and lactate. The body wants to get rid of carbon dioxide in the blood in order to increase the pH of the blood back to normal. This is done by increasing heart rate, breathing rate, and removing carbon dioxide and bringing in more oxygen. This is considered the body's response to a change in the lactic acid equilibrium. And now to scientist Prad, who will go more into depth into how the equations help and harm the lactic acid fermentation.
Thanks, Scientist Maddie. Now, as mentioned earlier, the body may not receive enough oxygen during exercise, and as a result, the body will resort to anaerobic respiration. Lactic acid is continuously produced through exercise, and a buildup of lactic acid can cause the muscles to stiffen. During intense exercise, the production of lactic acid will increase and will be much more than its resting levels, and the production of hydrogen ions will also increase in the blood. The accumulation of hydrogen ions can result in a decrease of muscle contraction abilities ultimately decreasing the performance of the athlete. So the equilibrium reaction helps the runner because, according to Le Chatelier's principle, during exercise the body increases the concentration of lactic acid through lactic acid fermentation. But when the concentration of the reactant, lactic acid, is increased, the change in the equation is balanced by the products, which are lactate and hydrogen ions, causing the reaction to shift right towards the products. Since the equation becomes balanced or reaches equilibria, the lactate produced helps the runner perform. Without the equilibrium reaction, the concentration of the lactic acid in the body would continue to increase, causing even more muscle stiffness and no beneficial results for the athlete. If the muscles did not produce enough lactate or hydrogen ions to counteract the increased concentration of lactic acid, then muscle fatigue can occur much more quickly, resulting in the loss of performance of the athlete. Contrarily, the accumulation of the hydrogen ions can cause the burn that runners feel during exercise, or any athletes feel during exercise, and it can be seen as a negative aspect to the equilibrium reactions of lactic acid, but it is quickly corrected with the use of the body's natural buffer. So overall, the equilibrium reactions for lactic acid can be seen as beneficial, and it can help any athlete during exercise. So now to Dr. Donalda Morris, who will tie the equilibrium reactions to its function in the body and its use in society.
Thanks, Brad. Hi, I'm Dr. Morris. I'm going to tell you all about the dangers in lactic acid and uses of lactic acid outside of the body. So, say for example that you just went on a log jog up and down hills, through trees, and over some fences. You get home and you're feeling pretty tired after this hard workout, and decide to shower and then go to bed. The next morning, you wake up and hop out of your bed. As you begin to walk down the stairs, you notice that your legs seem really stiff and sore. As you might have already guessed, this stiffness that you're feeling is a result of the lactic acid in your body that you built up while you were running. As mentioned previously, while running, a form of energy in the body known as ATP is metabolized from glucose to form pyruvate, which further gets broken down into ATP. However, when the body is not getting enough oxygen, pyruvate can alternatively be converted into lactic acid. High levels of lactic acid in the blood is known as hyperlacticemia, but is very common and it is not a serious condition. However, lactic acid acidosis is a medical condition that occurs when there is an excess amount of lactic acid in the blood. Lactic acid in the blood usually does not result in a change in pH of blood levels due to buffer systems previously mentioned. But when muscle tissues are not receiving enough oxygen, with this condition they go into shock and continue to increase levels of lactic acid in the blood. Individuals with this condition have kidneys that are unable to get rid of the excess acid in the body, making this condition gradually become more and more serious. Aside from being a big pain in the body, lactic acid is also found in some foods and used as a preservative. Using lactofermentation will allow some foods to last much longer than they would have without this method. By creating an anaerobic, which means no oxygen present, and acidic environment for the food to be stored in, this results in the bad bacteria not being able to grow, whereas the good bacteria are able to remain in the food. The difference between this method of food preservation versus the others is that there are more nutrients that are kept as opposed to preserving food in a can, for example. This method also maintains, and in some cases enhances flavors longer than any other method. Lastly, lactic acid is also found in many foods such as cheese, sourdough bread, yogurt, meat products, and pickled vegetables due to the acid naturally fermenting. So, just remember that next time you wake up from a day of exercising, that lactic acid can be a good thing since you worked hard enough for your body to reach that anaerobic zone. Keep it up, but don't forget to stretch.